Well, in our previous video, we were able to look at a simple structure of a C program. In this segment, I want us to do a very quick understanding of how to write a program that involves use of variables. I will delve into it. So we open our program again, and so we have to declare our preprocessor directives just as I had done before. So I will do that. Just to call the library functions, standard input output dot header. That is a library function or directive that will include the libraries that are required on the header of the program. So again, just as we said that a C program cannot work without having what we call a main function. So here we are doing the main function, that is to supply the arguments, and then we will do this. It is not necessary to go to the next line, but for beauty of the code or arranging the code in a manner that is nice, I'll do that. So here I want to write a program that can allow me to add two numbers, and in this addition I would show you in two ways. One where we only have the program doing the maths on its own, and then the second part would be when the program now allows you to enter values and then it computes the addition. So in this we will want to declare some variables. So we will say our variables are simply integers, and we have an integer a, and we are giving it a value. This is what we call assignment operator. We are assigning it a value of, let's say, 10. Then we are also having another one which is still an integer, and we are assigning it a value of 30, just like that. And then we have another variable which is C. So this time round we are not giving C anything, but rather we are now telling C, or the compiler, that our C is equals to what you guys have been doing. This is something that you've been doing for some time and you know how to do it. So it is A plus C, and you can notice here that we are terminating our statements using the semicolon. So after we have done this, where we have defined these integers and given them values, that is integer assigning, and these integers are what we are actually variable initialization, that is the best term. We have declared these variables to be of type integers. We also have float, we have double, we have characters. All those are different types of variables. Now the second statement here is going to add the two variables a and b and give us the output. So I'm going to simply print. So I will say printf, that is a function for output. Then I'm going to tell us something, probably the value, or the value of C is in this case it's going to be %. It is an integer, so it's going to be % of integer I. Then outside there, after the parent the quotes, I will have the comma followed by now the value of C, just that way. Then we will terminate, then have our return. Now that is the return statement, which I said earlier that if the program runs without an error, then this statement is reached, so that program is fine. Now let me build my program just like this, so that I see there's an error, and then you realize that there is no error. So let me run this to see the result of what we have done. And you can see right here we have a program saying the value of C is 40. Let's counter check with you. 10 plus 30 is actually 40. So that is basically how we write a program to add two numbers. In this case, the program is doing inbuilt work. You are not entering any value. So that way, just in those simple steps, you have been able to write a program which does addition. If you are to do maybe subtraction, probably you just need to do change over this simple here, and this time round just say the value of C is that. Of course, we need to exit this first by clicking any key or closing it here, so that we can activate this. When that console is running, then it means you cannot be able to access functionalities on your IDE. So I would build again, and then I would run the program, and you can see that my program has been able to give us a difference, the difference between A and B, and it's giving us -20, so which is very true. So as I've just mentioned, you can be able to play around here. If you are doing multiplication, you will use an asterisk, which is if you are using the United States keyboard layout, you would press Shift and number 8, then you will access that asterisk, which is for product or multiplication. So if we build this again and we go that way, you can see that the value of C is 300, and that is it, how to do your addition and subtraction, division, where you have only done initialization of variables. Now this kind of initialization, we call it initialization at creation. That could be the thing. The moment you create the variable, you give it you assign a value, so assigning it at creation. Then this bit where C is not given any value, and that value is applied here. When the program runs, then we say that is variable initialization during runtime. So we declare the variable here by giving it a data type and the name. Good. Having shown you how to go about that, allow me to take a few minutes to just teach you how then do we write a program that allows the user to enter values without just running the program and then waiting for something to happen. I want to be in control of the values that I enter. So I'm going to change a few things here. Remember, the names of variables cannot be reserved words like while, do, int, float. Those ones cannot. Also, you cannot have the name of a variable starting with a number. Neither would it also contain a special character. That will throw an error. Of course, maybe you need to look at the different errors that are there in a program, ranging from syntax errors, semantic errors, there's lexicon errors, there's logical errors, and even runtime errors that you need to be aware. So now let's write a program that will allow us to enter values of two numbers and then compute the maybe the addition. We can play around that. Once we are done with that, we will close for this session. Now look at what I'm doing here. I want to declare, so I will declare some integers. I would say int, let's call it number 1. That is allowed. Int number 1. We are also saying number 2. Then we have sum, like that. So in this case, I have declared one variable called number 1, and then I have a variable called number 2. This is, all of them are integers, the way I have declared them here. Then I'm going to have a printf statement, which is going now to tell or display something on the screen, and I'm just asking the user to enter the first number. Enter the first number, just like that, and then I terminate this statement. So anytime your program runs and comes to a point where it meets a comma, or not a comma but a semicolon, it will know that this is an end of that statement. Then I now need to introduce to you another very important function that we use in writing, or rather allowing. Print is to display. There is a one that we would allow us to accept data. We call it scan. Just like you scan documents, they take in a hard copy, it becomes a soft copy. So we have a function here called scan, and this is how it is written, scanf. Then inside that scanf, we are going to do a quotation, and then we will be able to say percentage I, just as I have done. So we are calling a percentage of I, and then we will put a comma, and then we will address. We are going to store this value in number 1. So in number 1. So this is referring to the address location that we are going to store our value at, and that value is an integer. That is why we are writing here %I. Great. So just like that, you would have allowed the user to see this statement that says enter the first number, then scanf %I number 1. Then we would also go and do the second one, printf again. We are almost closing this. So we say enter the second number, enter the second number. Then just as I said, you terminate that statement. Then you write there scanf. So you can try what should be written here. I believe if you see from the first one, it would be %I. Yes, why? Because we are dealing with an integer. As time goes by, I would expose us also to know how to write when we are not using integers, but probably double, floats, and the likes. So here, I would want you to call the address. So we are calling the address here, which is number 2. So I'll just click, because the IDE is also intelligent, it's able to sense. With that, then you say sum equals to, then you say number 1 plus number 2, just like this. Number 2. Then we will be able to come out here and say printf. We want to print our value, so we say here the sum is just like this. Then we say %I, and then we jump out there and just call sum like that. Then we terminate. Then we say return 0. Okay, our program is ready to build. So let's build it very quickly. We have an error. What is the error? We wrote this one wrongly. There is return, not return with a double N, single N. So we build again. Our program is fine. Let's run the program, and there you can see, enter the first number. Let's enter something like 23. Then enter the second number. Let's enter something like 25. Then the output is the sum is 48. Just like that, you have been able to build your program. So follow this channel for your own learning, that you may have an understanding of many other things. In the next segment, I'm looking forward to show you some more things that we can do to make our program better. If you found this video educative, like it, share, reshare, follow and like as we move along together.